The goal of the smart ground-based laser object tracker is to help reduce military casualties on the battlefield before it's too late, by using object detection programming to help spot and track insurgent vehicles that may be suspicious or dangerous. Gone are the days that our troops missed to place themselves in dangerous situations by getting blindsided by vehicle suicide bombers.
For our concept selection, we began by creating a concept fund to obtain the alternative pathways we could follow. Here are the four alternatives that we obtained by combining the different options in each category. Following this step, we used weights and scores according to the importance of the objectives and how we would be able to fulfill them by selecting each option. We can see that the highest weighted scores are option 2 and 4. After carefully evaluating these two options, we decided that option 2 would suit the squad best as it fit our budget while still giving us several advantages, such as a high-quality camera, scalable algorithms, and easy manufacturing.
The smart ground-based laser object tracker block diagram has three levels: level 0, level 1, and level 2. Here is level 0. The S-Log will have two inputs, which are power and detector input. The only output would be the video output. This is level 1, which shows that it's separated into different modules. This is how it works. First, the battery powers on the pen tilt assembly, then the laptop. Then the detector sends an image to the laptop, which collects the data. It then gives the information to the microcontroller to send the data to the pen tilt assembly that makes it work. Then the pen tilt assembly sends in the laser data back to the laptop, which then this is how we get the video output with predicted object tracking. Here are a few in-depth diagrams that are in level 2. In here is detector, which the image goes through the lens, then to the cameras, and then the outputs the image data. Here's a more in-depth look of the laptop, how to process the images. The microcontroller is running using a motion control algorithm. Lastly, the pen tilt assembly uses the laser's pen tilt plate and servo motors to allow it to move around.
Here we have the Smart Ground-Based Laser Object Tracker, or SCLOT. It has a detector, LiDAR, pan tilt assembly, battery, and tripod. The detector utilizes a 2 megapixel global shutter camera and a distortion reducing lens. The battery pack allows for the device to be portable and versatile. Here we can see the SCLOT is tracking a vehicle outdoors in real time. The custom SCLOT controller GUI allows for the user to interface with the device easily. The user can switch between automatic tracking or manual tracking. Here, the SCLOT is tracking a vehicle moving at approximately 30 kilometers an hour. The vehicle is now moving at 50 kilometers an hour. The LiDAR laser on the SCLOT measures that the vehicle is approximately 23 meters away from the device. The SCLOT can measure vehicles at variable distances. The device now measured the vehicle to be approximately 98 meters away from the SCLOT.